For the next part of this AMT, we're going to be using different strategies in base 5 to solve the problem 132 times 24. So the first step I'm doing is I'm going to color code these values, the place values, because I find that makes it easier for me to multiply. And the first strategy that we're going to be using is partial products. And Dr. Coster, I'm so sorry. I'm just now realizing that when I filmed these videos, I wrote partial sums. So I apologize. I meant to write partial products. I must have just been moving too quickly. So I apologize about that. Let's just pretend it says partial products. So just like we did in solving for partial products in base 10, we're going to be moving from left to right. So I'm starting with the 100 from 132. Because we're working from left to right, and 100 is going to be our first place value on the left in that first number of 132. And we're going to multiply it by the first number on the left in our second number. So that's 24, so we're going to do 100 times 20. Then moving to the right in our second number, we're doing 100 times 4 for the ones value. So you'll see 20 and 4 being multiplied various different times. Because those are the two values that we're multiplying by. Then we're doing 30 times 20 and 30 times 4 when we're working to the right. In 132, 30s would be our next place value. And then finally 2 times 20 and 2 times 4. After writing all of these multiplications out, we're going to solve for the products for each of them in base 5. So for 120, we're going to find our answer to be 2,000. I want to make it a preface that for base 5, we are going to be using a lot of multiplying the first digits and then adding on the zeros. So I wanted to clarify why this works. So multiplying 100 times 20 is the same thing as doing 1 times 10 times 10, because we know 10 times 10 is 100. 10 times 10 is representing those two digits of 100 as well. And then 20 is the same thing as saying 2 times 10. And that's two groups of 10. So 100 times 20 is the same thing as doing 1 times 10 times 10 times 20 times 10. So the first thing I did to make this simple is we're multiplying the first digits that don't have 2 is going to be 2. And then we take all of our 10s, so 10 times 10 times 10, and we get 1,000. 2 times 1,000 is 2,000. So this kind of just proves why we can do, like for instance, for 100 times 20, we can do 1 times 2, and then put on the 3 extra zeros after that because we know that it's going to be 1,000. So now I'm just taking my base 5 multiplication chart, and I'm showing that 2 times 1 is 2, and we're adding on those 3 zeros. So I just wanted to make that crystal clear for the future of why I'm using this method. So we're doing 100 times 4, so I'm starting with 1 times 4, which is 4. And then we're going to tack on those extra zeros because we would be doing 10 times 10 times 4. Again, 30 times 20, I'm doing 3 times 2 is 11. And since we'd be doing 10 times 10, it's going to be 1,100. 30 times 4 on the number chart, 3 times 4 is 22. So we're going to do 220 for 30 times 4. Then we have 2 times 20, so I'm doing 2 times 2 is 4. Since we have two groups of 10, it's going to be 40. And then finally, 2 times 4 equals 13. So that's going to be our last product for 2 times 4. Then, as similarly as to how we did it in base 10, we're going to add all of our products up together using standard algorithm for addition. So working from the right to the left in addition, we have 3 in the ones value. Then here we're doing 2 plus 4 plus 1. So I'm going from 2, adding 1, 2, 3, 4 to find 11, and then adding that last one to find 12 to be our answer for the tens value. So I'm going to put the 2 in underneath and carry the 1 up to the hundredths value up top. Then we're adding 1 plus 4 plus 1 plus 2. So 1 plus 1, 2, 3, 4 is 10, plus 1 is 11, plus 2 is going to be 13. So we're going to put our 3 and then carry the 1 up to the thousands value. And then 1 plus 1, 2 is 3, plus our final one is going to be 4. So the answer for this problem is 4,323 in partial sums.